Question: what is unit weight of R.C.C and P.C.C? Answer: the unit weight of reinforced concrete, R.C.C, typically ranges from 24 to 25 kilonewtons per cubic meter, kNm superscript 3, or approximately 2400 to 2500 kilograms per cubic meter, kgm superscript 3. On the other hand, the unit weight of plain cement concrete, P.C.C, generally falls between 22 to 24 kilonewtons per cubic meter, kNm superscript 3, or approximately 2200 to 2400 kilograms per cubic meter, kgm superscript 3. These values may vary slightly based on the composition of the concrete mix and any additives used during construction. Question: what is the unit weight of steel? Answer: the unit weight of steel, also known as the specific weight, typically ranges between 7,750 kilograms per cubic meter to 8,050 kilograms per cubic meter, depending on the specific type and grade of steel. This value serves as a crucial parameter in engineering calculations, especially in structural design and construction projects. Question: how to find the weight of steel bar? Answer: to find the weight of a steel bar, you can use the formula weight-volume density. First, calculate the volume of the steel bar by multiplying its length, width, and height. Then, multiply the volume by the density of steel, which is typically around 7,850 kilograms per cubic meter. This will give you the weight of the steel bar in kilograms. Question: what is compressive strength of brick? Answer: compressive strength of brick refers to the maximum amount of load a brick can withstand per unit area without breaking or crumbling under compression. It is a crucial parameter in determining the quality and durability of bricks, especially in construction projects. Typically, the compressive strength of bricks ranges from about 3.5 nmm superscript 2 to 20 nmm superscript 2, depending on factors such as the type of material used, manufacturing process, and quality control measures. Testing for compressive strength involves subjecting a sample brick to gradually increasing pressure until it fails, with the maximum force applied recorded as the compressive strength. Question: what is the slope of staircase? Answer: the slope of a staircase, also known as the stair pitch or stair angle, refers to the angle at which the stairs ascend or descend. It's typically measured in degrees or as a ratio of rise over run. The slope of a staircase is determined by dividing the vertical rise of the stairs, the height between two consecutive steps, by the horizontal depth, the horizontal distance from the front of one step to the front of the next step, also known as the run. This ratio or angle can vary depending on building codes, architectural design, and accessibility requirements. In general, steeper slopes provide for taller rises between steps, while shallower slopes result in shorter rises and longer runs, making the stairs easier to climb. Question: what do you mean by segregation? Answer: segregation refers to the enforced separation of different racial, ethnic, or other groups within a society, often leading to unequal treatment, limited opportunities, and social division. Historically, segregation has been most commonly associated with the systematic separation of African Americans from whites in the United States, particularly during the Jim Crow era. This practice extended to various aspects of life, including housing, education, employment, and public facilities, perpetuating deep-rooted inequalities and injustices. While significant strides have been made to combat segregation, its effects continue to resonate in many societies worldwide, highlighting ongoing challenges in achieving true equality and social integration. Question: when we go for pile foundation? Answer: soil conditions. Pile foundations are typically chosen when the soil at the construction site lacks the necessary bearing capacity to support the structure adequately. This can include soft soils, expansive clays, or loose granular soils. Heavy loads. Pile foundations are ideal for supporting structures subjected to heavy loads, such as high-rise buildings, bridges, and industrial facilities. The piles transfer the load of the structure to deeper, more stable layers of soil or rock. Waterlogged sites. In areas with high groundwater levels or where the site is prone to flooding, pile foundations offer a reliable solution. They can be driven deep into the ground to reach load-bearing strata unaffected by water saturation. Remedial measures. Pile foundations are also used as a remedial measure when existing foundations fail to provide adequate support. They can be installed alongside or instead of shallow foundations to enhance stability and prevent settlement issues. Environmental considerations. In environmentally sensitive areas where excavation is restricted, pile foundations provide a minimally invasive solution. They require less disturbance to the surrounding land and can be installed with minimal disruption to the ecosystem. Question: what is the volume of cement bag? 50 kilograms. Answer: the volume of a cement bag weighing 50 kilograms can vary depending on factors such as the density of the cement and the packaging method used by the manufacturer. However, typically, a standard cement bag of 50 kilograms has a volume of around 0.0347 cubic meters, m superscript 3, or 34.7 liters. It's important to note that this value may vary slightly based on regional standards and packaging variations. Question: what is least count of theodolite and compass? Answer: the least count of a theodolite and compass depends on their respective scales and mechanisms. Generally, the least count of a theodolite is typically around 20 to 30 seconds, while for a compass, it can vary but is often around 1 degree or even less. The least count represents the smallest angle that can be measured accurately using the instrument's scale and vernier or other measuring devices. Question: what is the least cover for the slab, beam, column, and footing? Answer: in construction, minimum cover refers to the amount of protective concrete cover required to ensure the reinforcement within structural elements remains adequately protected from environmental factors and corrosion. The least cover requirements vary depending on the element. Slab. The minimum cover for a slab typically ranges from 20 to 25 mm, approximately 0.79 to 0.98 inches, depending on factors such as exposure conditions and reinforcement diameter. Beams generally require a minimum cover of 25 mm, approximately 0.98 inches, to protect the reinforcement adequately. Columns require a minimum cover of 40 mm, approximately 1.57 inches, to provide sufficient protection for the reinforcement. Footings, being in direct contact with the ground, typically have a minimum cover requirement of 50 mm, approximately 1.97 inches, to safeguard the reinforcement against corrosion and other forms of deterioration. It's crucial to adhere to these minimum cover requirements to maintain the structural integrity and longevity of the building elements. Deviation from these specifications can compromise the durability and safety of the structure over time.